Okay, this is the sanitary drawing. Now, our sanitary drawing doesn't have a panel that shows all the pipes under the house, you know, from the CRs and the sinks and the showers, and every place water's introduced or consumed, there's a pipe going out from under the house. We did put them, all the wet areas on an exterior wall. And that lets us run most of our pipe outside of the building in case there's problems. You have that short piece, but that piece of pipe goes under the tie beam on the side of the house, because do you really want to bury a sewage line any closer than that to the surface? Because they're just barely flush with the surface. The tie beam is hardly ever under the ground. It's pretty much on the grade of the actual site. Anyway, all sanitary drawings will want what you see in here. This shows you the construction of the septic tank. It gives you the size. You have general notes on the construction for strength and amount of rebar. The lower left corner is showing that it's got a gravel bed on one end, which means there's no poured concrete bottom. It's the leaching part. And then the digester is on the right. It's got a concrete floor. It shows that there's 3 cleanouts. Not that you'd want to go into a digester, but you might want to put a 4-inch hose down there and have it cleaned out. If you don't operate a septic tank correctly, like if you put a lot of muriatic acid and bleach and all kinds of other stuff in there that kills the bacteria, then it quits working. But normally what you're going to find in the bottom of a working digester is sand that you get when you wash off vegetables and things in the sink. You'll find bone fragments from when they grind hamburger and stuff. You know, they always have a few bones. Sometimes they have a lot of bones, but that doesn't digest. The bones don't digest. And anything you've sent down a toilet or a sink that's not biodegradable, it'll be laying in the bottom. And it'll be a bunch of slime down there with it. But generally, it's not going to be, you know, undissolved poo. It's going to be things that are more like solids than biodegradable stuff. Now, this tank on the permit, we added another section to it beside it. And the small one on the end over the gravel, that one would, on the one we're building, has got a floor in it straight across. So you have the big one, which would be the right side tank you have here. It goes into a second digester, and from that it comes back to the other end on the other side. And that end, it's actually got a concrete floor as well, except that there's an 18-inch hole in the floor down to the right. And underneath of the entire septic tank, that's one of the reasons we made it bigger, is gravel. There's 9 inches of gravel. 10, 20, 22 and a half centimeters of gravel. The gravel also goes out to the dug hole, not just where the walls and floor were put in the septic tank, but it goes clear out to the size of the excavation. This is our leach field. Our septic tank is deeper than the one in the drawing here. Every aspect of the septic tank exceeds the drawing. You can't turn in a drawing and then do a lesser job. They'll call you on that. And you may be putting another one right beside it or digging it up altogether. But there's not much trouble if you build something better. The important things on a septic tank is the elevation of the pipes that go from place to place. Now this one here is copied off of an approved drawing. Well, not exactly copied, but it's really similar. Well, you see that T-shaped affair in the middle. It's a vent line down into the tank and one to the next section. That actually doesn't belong up there. It's working on this one because they have a standpipe. Goes down to the well below the water level. That line across the top It's got a dimension on it like 9 inches, but you can't read it because it's too small. That's airspace. So everything is referenced to the surface level of the water. Where it comes in, when your sanitary stuff comes in, it can't be underwater. Otherwise, it'll back pressure the flow coming out, slow it down, and then your 1/4 inch to the foot grade, that's 1 in 48. 1 part in 48. I don't care if you're talking meters, centimeters, inches, thousandths of an inch. 1 part in 48. It's simple. But that works. The water doesn't outrun the poo, and it doesn't go so slow that everything settles out and just sits in the pipe and the water slowly drains away. It's worked over hundreds of years. It's still the right number. Anyway, it comes in, got to fall into air. Don't put a pipe turned down under the water. Even with good vents and stuff, that can cause you trouble. There's no use asking for trouble. Okay, the transfer to the out of the digester into the leaching tank or your secondary digester if you use one, that has to be down well below the surface but off the bottom. Floating poo is on top. You don't want to send that to the second part. Gravel, sand, bones, all that kind of crap is in the bottom of the digester. You don't want to suck that up and send it into the next part. You want to confine all the problems to the digester, the thing that people come by and put a truck to and suck it out for you. So if you just put your pipe from one section to the other, middle of the wall, middle of the water column, then it'll go through that pipe because water's self-leveling. The next one will have the same water level as the first one. So basically, section 1 to section 2 would be, if you were using a 3-section tank, would be in the middle of the wall. If you're using a 2-section tank like this, what they have got is a standpipe. That makes the it confuses the water in the second tank as to what the really height is supposed to be, and anything that goes into the leach field you don't care if that tank is 3/4 air, because all you're trying to do is get rid of it when it gets in there, shove it into the leach field, and hope it goes into the ground. If you have a real tall septic tank, 8 feet and more, it's like 12 feet even, but 8 feet gets into the realm of what works. You basically have hydraulic pressure, the weight of the water trying to push it into the leach field. If you had a flat tank that was total 39 inches, a meter deep, then there's no real water pressure once you've got 9 inches of airspace. There's nothing pushing it into the gravel. The second part of that deal is if your ground doesn't drain, if the water doesn't go away, well, you got a problem. I haven't got much solution on that. There is an overflow. It's called outlet. And if the water gets up to the point where it would back up your incoming water, then you have to get rid of it. So you have a line there. Now you got to remember, this water's gone through the digester, and all the biodegradable stuff is out of it. It's nearly clear water at that point, sort of a grayish but clear. Put a bunch of it in a big jug and look through it. It's got a gray tint to it, but it looks like clear if you just dumped it in a water glass. You can water plants with it. In our case, we're putting baker's yeast in the second digester, and then dumping it into the third one. Now, say you had this a two tank system, and you wanted to do some other water cleanup, another stage in the existing tank. You can put like a 6 or 8 inch PVC pipe, stand it up in that tank, down into your gravel bed or whatever you got underneath of it. Hopefully there's a gravel bed. I don't know where it'd go if you didn't have that. But you can put a standpipe in there to let the water build up to the height of the standpipe. As long as the top of that pipe is below the incoming water level, the water flows into it and goes down. At that point, you can concrete that second tank, because a 6-inch pipe, I don't know how many gallons a minute would fall through a 6-inch pipe, but it's a lot. Come on, computer. There we go. But you can no matter how many sections you have, you can make the last one into a working section with a standpipe. And if you learn anything else on Septic Tank 101, that would be it. Septic tank digesters require oxygen. You have to have vents. Now this one is drawn here with 3 small vents out of the lid of the tank. You'll notice that there are 2 of them, 2 vents in the first section, an in and an out. The vent for that septic tank will not look like what you see in this drawing. They have to be at different heights. Now you can come up out of the top or the sidewall of a septic tank for a vent, as long as it's above the water level, and go over and run it up through something, a column in the house or whatever, or just straight up if you have something to hook it to, and get it up above the roof, and it'll thermal siphon. The heat on the side of the pipe will make it the air lighter. It'll go up. It'll draw air in from in this case, the one on the left. But you have to send air through. That's why you got an airspace on top of the tank. The exchange of oxygen and the methane that rises off, it's got to go someplace too. If you completely cap up a septic tank, you've not got a septic tank. So you need air. What we're doing is we're putting a couple of 6-inch sleeves through all the tops of the walls above the water level, and we're going to vent that air someplace away from the house. All we have to do is have an elbow and turn it straight up for now. But if we have any kind of odors at all, a working septic tank does not have odors. But if we have some, while we're trying to figure it out, we'll probably extend one of those pipes down the property out back, down our little bit of a grade, and let it vent air through one end to the other. What's the time? 12:11. I don't think there's anything else we need to talk to about septic tanks. Oh, it's got a scale on it as well as the drawings. This tank will look large to a lot of people. It's 5.5 meters long and more than 1 meter wide. But this is for something with. This one was drawn for 4 apartments on top of a garage, where they work on cars and stuff, and then they have auto parts on one end. So it's for the people that live there and the people that work there and customers that come in, or people just come in to use the septic tank. Okay, I think I beat that to death now. Let me close this and see if we can start another one on another. This is permit sheets. We're doing the sheets that you have to turn in. This one goes to your sanitary part. As long as, and also a copy of every other sheet you got, though they don't really have much to do with them. They'll all look at something that could concern them, like the guy that takes care of the sewage, and well, there's no sewage treatment in the provinces. You don't have a septic tank; it just dumps on top of the ground or under the house. What kind of sense is that? But this guy might want to know how you're going to connect up your sanitary lines where they go under the slab. He might want to look at that. He can make comments about it. He can make you change it. And if they're concerned enough that they ask you to change your design, you probably want to do that. You know, it just makes good sense. The fire department changed ours. He changed the floor plan. That's the one you don't want them to change. He required 2 means of egress out of every room. That was not hard to do. It was just a matter of putting doors in walls, because it didn't move any walls. But when we got looking at it, we says, well, we have this hall between the master bedroom and bedroom 2, and a set of stairs in that little section that goes up to the roof. We might want to do away with that hall and stretch that a little wider and make an actual room that's big enough for the stairs and put the laundry equipment in there. So we did move a little bit of walls there, but the cure for the fire department was to put in a door between each room where you could either go into the central core of the house in the atrium, or you could go to the next room and the room after that and room after that, whatever. Now they have requirements on from the fire department. You can't have a exterior door or several other things that take the place of an exterior door that requires any special knowledge or any tool to open. In other words, an average person walks off the street, they should be able to get out that door and with a smoke-filled house in a few seconds. That makes it pretty much the slide bolt kind of thing that you see on your gate out front. I don't feel at all comfortable with that. We elected to put a door lock on the exterior doors. Their response to that was all the window grills had to be hinged to open. And again, no special knowledge and no tools. We're back to having to make the outside doors operable. You know, we weren't originally going to have anything but security grills in some of these holes so we get air circulation. But we got 4 or 5 outs on this. Not like we put ourselves in a corner. But the fire department can require more doors. They can require a wider hall. If your hall is not a meter plus in width, ours was 36 inches because it wasn't to be used for anything. It was just an emergency escape hall. It really didn't do anything. It was just in the drawing. But they required it to be wider. And we said, well, if we got to redraw it and make it wider, what else can we do while we're doing it? And that's why we made that room bigger. And the ones the rest of the way around the building a little smaller. You don't even miss it in the other rooms, but it's a really a nice area now. It's architecturally interesting compared to this regular old trapezoidal-shaped room. Okay, we did redraw that drawing because it changed the floor plan, and that was another trip to back or for 9 copies, and then we had to go around and collect up all the ones that we'd give to everybody because they were no longer accurate. So the fire department and sanitary, they can be a problem. The electrical was a problem. No problem with the on-site location or the shape of the house or the floor plan or anything from the barangay or all those sheets just went right on through. Oh, these sheets have to be signed by professional people, licensed people. Like our structural analysis had to go through a civil engineer. And that was our cousin. Everybody's got cousins. We looked through our list of cousins when we started looking for signatures. And then he helped us a lot with this. He loaned me this septic tank print out of a set he'd drawn for somebody else. He's an architect. So, I mean, if he wasn't a cousin, he would still probably lend you that. If he's a structural engineer, he's not into doing the architecture and floor plans and perspective views and things. He analyzes concrete beams and load paths and things like that. But we didn't have any trouble with that. Our house is overbuilt. In fact, the only sheet we really had trouble with was they rejected the electrical print. And the fire department, he said, look, I don't want to be a whatever about this, but there are rules, and you're violating a couple of them. So here's the way the law reads, and he read it. There's nobody give you a copy of it, but he read it to us, and we looked at it and says, okay, it's no problem, except that we had to buy 10 more doors. You know, you have to pay for those doors. But what we gained is we didn't have to pour concrete in the door openings. And concrete's a heavy, expensive material, the cement bags in particular. Our house being poured concrete, we use bigger doors than we need because it's less concrete. And we put interior windows in the house, like the master kitchen to the living room, entry room kind of thing. We use all our door forms and our big window form in that wall. It sort of connects the rooms. There's a window between the master bedroom and the master bath, and that's another huge window. So those all eliminated rebar and eliminated poured concrete. So they probably paid for the doors. you know, they're less expensive than the concrete. And didn't have to mix the concrete and made the pour for that day smaller. And there goes the picture. It came back. So let me close this and go look for another print. Oh, and if you want a thumbs up or thumbs down, go ahead. If you thumbs down, I appreciate a comment, though it's not required. I appreciate a comment what you didn't like about it. Repeat myself too much, don't like the color of the drawing, shaky camera work, you know, whatever you didn't like, it's fine. You can comment on it. It doesn't make any difference to YouTube. It doesn't change anything with them. It's like the thumbs up and thumbs down. I don't know if that has any effect on YouTube, whether they let me keep publishing or not. I call this publishing. I don't know what everybody else calls it. Anyway, if you've gained anything from it, I think thumbs up would tell me I'm on the right track. Thumbs down, I'd like a comment from you to know why it's so awful. Other than it's amateurish and it's not edited. I understand that, but you can put it down. We might learn enough to go out and find some editing software. Okay, pause on this. We're going to come back with a whole nother video. Okay, here's another in the never-ending permit sheets. This is the electrical plan. I'm pretty sure this is my original plan, not the one that they redid for me, which you can't tell it apart. They changed a couple of things in the calculation. I'm not sure how they did that because it was a print. You really can't erase things out of a print. Not a CAD drawing. I can erase everything and change it, and you can't tell it's ever been changed because I got the original file. But what they had was a blueprint, a paper blueprint. But they managed to change, or they tell me they changed it. I never really looked. Anyway, on the top, it's a calculations like spreadsheet. On the bottom left, it's the floor plan of your house and how the receptacles are run. They're basically daisy chained. Some of the lights have to have a switch. Some may or may not be daisy chained. How you get from a particular thing, the path back to the circuit breaker box. It's pretty much so the electrician, like, that show up? Yes, it shows up. Like here you have a hole in the wall. There's no reason not to have receptacles on both sides of that wall. I mean, it's just a matter of drilling a hole through the wall or cast, in our case we have cast concrete. So we just put a block in either side and then knocked it out with a electric chisel. But that puts a receptacle in this room off a some breaker, as well as this one over here, so off a some breaker. The next room, you have that breaker and the breaker for this room on the other receptacle. So every room basically has two sources of receptacle electricity. Oh, this floor plan is not exactly what we ended up with. It's got this hall in it. And we had to, the hall was 3 inches too narrow for the fire department. So we just basically moved this wall over to there and did away with this wall. It's one big open room now, just pretty much like these. This was the pantry. This is still the kitchen. And what we did is we made this whole segment, didn't run with that hall. See, the halls were for, in my opinion, they were drawn in there for fire egress. Any room in the house dumped into the atrium. And from the atrium, you had a hall down here and right to an outside door. Outside door here, outside door there, outside door down here someplace. Anyway, they didn't like that. They didn't like the width of the halls. And then there was only one means of egress from a room, like here. You have a door coming out of that room. But they all go to a common place, and if that's where you're getting smoke, if somebody lights up a couch in there, then you have to go stand by the window until the smoke clears. Anyway, we're looking at electrical. See, I can... Yeah. Windows reinstalled or installed some updates. Though I had updates turned off, they decided to change something, and I've lost my toolbar up here that has the pan and zoom and all those kinds of functions. I'm gonna have to reinstall Rhino tonight. This is a key, and it shows you what all the little symbols over here. See this that's like 4 lights on a ceiling fan kind of deal, hang off the bottom. Anyway, there's 4 bulbs in that. And if you look at this symbol, it tells you that's a chandelier, so it's a light in the middle of the room. This list is pretty much a standard list. Here it says this kind of outlet is air conditioning outlet, grounding type, automatic reset. We don't have air conditioning, but just so that anybody that adds something to your print has got a symbol, and the symbol will match up to your other prints, you just put the whole block of symbols in the drawing and use the ones that you put in here. Oh, there's another little interesting thing. This house was drawn up to be built out of concrete blocks, which let us count the number of blocks. And all the bond on the blocks has to come out to the door openings and things like that. Oh, also, our columns are different than they do here. These are like 30 by 35, 30 this way and 35 that long, or 28 this way, 35 that long, and this is shorter. You got a notch here in the side of the column, 3 places, and that's to anchor the walls. Rather than trying to drill and put a piece of rebar in here and tie it to the rebars in that you bend over into the blocks and stuff, we just did it that way. This column and this column use the exact same form to make them, because when the panel for the form is pretty much straight across here, that makes this panel and that panel the same length, because they're going between the other 2 panels. So that lets you just turn it around and put this one over here and this one over there, and that goes from this to that. So we made 10 of these, and then we come back and flipped them. Just put them together. You know, we have to take them apart to get them off and put them back together. So we flipped them and made the inner ones out of the same form. And when we went to poured concrete construction, we only needed enough forms to do a spoke or to do an outside wall. And then we used them 36 times. They're substantial forms. It's still easier to use a toolbar. I wish that update hadn't done away with it. Well, let's go bigger right off rather than having to change it. Okay, this house is showing 26 circuit breakers, 26 individual circuits. That should be 1-6. I don't. Yeah, nobody's perfect. You have the number of the circuit, that's the breaker that it goes to in the breaker panel, the description of what you're feeding off of it, the number of outlets for various kitchen appliances. That's the stuff that sits on the counter, but not the refrigerator. See, refrigerator and dishwasher and all that, they'll have their own, because it might be a different amp circuit breaker. Like you might need a 30 on a or 40 even on a dishwasher. A refrigerator is only like 6 amps, so it would be on a 15. And also, you notice that there's only one item on 1-3 is the refrigerator. It's got its own breaker. So we got number of outlets. If you're using LED bulbs, like whatever that was, it's got 8 bulbs. They're 4 watts apiece. Sounds ludicrous to be talking about a 4-watt light bulb. The light bulb in a U.S. refrigerator is 15 watts. A Christmas tree light bulb is 15 watts. But a 4-watt LED, our ceiling fans in the house we stay in had I guess you call them receptacles. What do you call a light fixture? Held 4 bulbs. We put 4 4-watt bulbs in it. It was unpleasantly bright in here. So we took 2 of them out, and we left 2 that pointed towards something we wanted more light on in the room. But now we got these empty things in the fixture. But in retrospect, we should have had 6-watt bulbs. And if we ever have to replace one of them, we'll put 6 watts in about half the ones in this house. And we'll probably, I only priced 6 watts, 192 pesos, and 9 watts, it's 220 some pesos at Wilcon. This would have been a single click, except that Windows has changed my mess. For instance here, 8 bulbs times 4 watts each, that's 32 watts. If you divide the 220 volts by 32, you end up with the amps. Now you notice that we're using 0.145, less than 2 amps for 8 bulbs, okay? Less than 2. This 2 would be, the number would be on the other side of the decimal point if it was 1 point something. But this is 0.145 amps. Smallest breaker they sell in the Philippines that we can determine, I mean house type breaker, is 15. So we can't put wire downstream of the breaker that's not able to support the amps that the breaker would send through it. So we have to use number 14 wire, which carries 15 amps, nominal is 15. We have 15 amp capability and 0.145 actual amps. The wire's 10 times bigger and also many times more expensive. But available, you can get it anywhere. So that's just one, look at this one. 1/100th of an amp. Oh, well, actually almost 2. We'll call that 2/100th of an amp. It's on a 15 amp breaker. Only in the Philippines. More fun in the Philippines. It is more.